Hi, everyone, and welcome to what promises to be a unique and entertaining session at PyData Global. Up next, we have someone that shows that data and laughter can belong together. Evan Wimpey is an analytics professional with a background in statistics and economics, but he's not your typical data science. He's also a stand up comedian who uses humor to make analytics accessible and fun. Evan has performed data science comedy at conferences globally and is the author of Predictable Jokes, a book that continues his mission of combining analytics and laughs. Today, Evan's session is titled Python is a Joke. Please join me in giving a warm welcome to Evan Wimpey.
Hey, perfect. Jim, thanks so much. Welcome, everybody. Good morning, good afternoon, perhaps, or perhaps even good evening. The introductions at a global conference just tend to take a lot longer. My name's Evan Wimpey. I'm a data comedian. Going to be doing a little stand-up comedy for you today. So a little bit different here. Now, look, I know it's not your typical stand-up comedy venue. So I invite you wherever you are, if you're at work, if you're at home, in the classroom, it doesn't matter. Just feel free to go ahead and laugh out loud. I checked with your boss or your partner or whoever you're with, and they said, totally fine. Just go ahead and laugh out loud. We want to hear it. I won't be able to see you or hear you, but I will sense it. Okay. And it will make for a more enjoyable experience for all. I have sat through a couple of the sessions so far. It's been a great conference so far. And I'm sort of aware that you need to start out as a speaker with your credentials. I think folks sort of need to know whether or not they should actually pay any attention to me or not. So I'll go ahead and be upfront. I do not have a PhD in data comedy. So I just saw about half the people leave. I actually didn't even study data comedy. My background, I originally studied economics, and for a while I considered a career as an economics comedian, but there's no demand. And so as an economist, I did a lot of reading. I had a subscription to Harvard Business Review. As a comedian, I don't anymore because I can't afford it. But as an economist, I read an issue in Harvard Business Review said data science is the sexiest job of the 21st century. Some of you might have read that. Maybe that's what got you into data science as well. I thought, hey, all right, that's good for me. I need all the help that I can get. I'm an economist. That was actually voted least sexy job of like the last 7 or maybe 8 centuries in a row. So I need all the help I can get. And I did it. I went back to school. I studied advanced analytics, and I became a data scientist. And I did not get any sexier, no, but I did love being a data scientist. It's like such a magical feeling to be a data scientist. I felt like a Harry Potter, not because I was a real wizard or anything. It's just because I was all of a sudden fluent in the Python language, which was great, unlocks a lot of doors. Um, as a data scientist, I was really terrible. I was a really awful data scientist. Just absolutely the worst data scientist, and I didn't know I didn't know I was that bad. I build these models that I thought were pretty good. I show my colleagues, I say, hey, check out this model I built. Evan, what is this, a joke? So now here I am. But I did build one model that was really good. I built a great model that was one of the very first models that I ever built. It wasn't the first model I ever built, because the first model I ever built it's probably the same as the first model you ever built. And for some of you students, it's probably the model that you're building right now. And that's, of course, who will survive the Titanic. But I don't really understand why we're still building that model. The crash happened over 25 years ago. It looks like we'd have more important research questions to focus on, but I don't want to make light of it. We want to bring closure to those families. One day we'll crack the nut. We'll figure out who will survive the Titanic. But my Titanic model was terrible. Just went up in flames, just like the ship, actually. But the model that I built that was really good was a stock picking model. Maybe my background in economics, but I built a stock picking model. Bears and bulls riding the market. My model was so good. It was 90% accurate at predicting for an individual stock whether it would go up or down the next day. 90% accurate. Now, For those of you not in the market, you may not realize that that's that's basically a money printing machine. Okay, 90% accurate, knowing whether stock is going to go up or down the next day. And I tell you what, what's all the rage right now is gigantic models, huge transformer architectures with billions of parameters. No, no way, not for me. I'm too simple minded. So a simple model is what's right for me. And I built this model, this 90% accurate model, 3 features. That's all I needed. 3 features. That's it. And I probably shouldn't do this because I might lose my edge if this gets out. But I'm going to tell you what the 3 features were. You can go and use this model. Only 3 features. That's all it needs. Stock's price yesterday, the stock's price today, and the stock's price tomorrow. That's it. With those 3 features, I built a model, used all of my statistical prowess and my data science acumen, and I built a model that is only forgetting 10% of tomorrow's stock prices. I mean, I was proud of it. I thought this one was really good. I showed this one to my colleagues. I say, check out this model that I built. They said, Evan, that's a leak from the future, which means I'm like super advanced, like ahead of my time even. So it was really impressive. It was really good. Proud of that one. I actually used that model to day trade for a while, and now I'm a comedian. It was good. It was good. To those of you that are particularly astute, you may have noticed that I'm using the past tense when I say I was a bad data scientist, or but past or past participle or present prefect, past participle, something. It was back ago. I was a bad data scientist. I'm gonna give you the spoiler. I did not become a good data scientist. Okay, I was actually such a bad data scientist that I'm not a data scientist anymore. I was so bad that I was actually promoted to director. Okay, and so now it's just like a whole new world of problems that I got to deal with. And uh, I I do want to defend the data science industry for a little bit because a lot of people say that data scientists have bad software engineering practices. It's we're deploying notebooks and no documentation. Who even reads documentation? But look, I was a terrible data scientist and I got promoted straight to director. And that is straight out of the software engineering playbook. All right. This guy's terrible at his job. Don't let him touch the code anymore. Get him out. So that's good. It's software engineering 101. And now I'm a director. Whole bunch of problems that you got to worry about as a director. I think the biggest one for me is probably communication. It's communication. And I'll tell a story real quick. Is that okay? Can I tell a story? I hope it's okay. I've just been telling stories. I'm gonna tell some more stories. One of my first projects as a director was consulting and was working with the Jelly of the Month Club. Okay, that's the gift that just keeps on giving the whole year round. The Jelly of the Month Club was in a bit of a rough stretch. Okay, it's been years and years since Christmas Vacation was released. Nobody even knows who they are anymore. Kudos to you if you know this reference. But we met with their sales team, and I had a meeting with their sales director. And I was the dumbest data scientist, and I became data science director. Can you just imagine how dumb a sales director must be? Okay, but that's who I've got to meet with, and it's tough to communicate because it feels like we're just speaking different languages here. And he comes to me, he says, Evan, we're in trouble. Sales numbers are way down. It's fourth quarter. We need to get new memberships. We need to get new joins. I said, joins? Joins? You need joins? The data team can support that. The data team can get you joins. He said, really? That's great. I said, yeah, but we're gonna need SQL. He said, that's good. We've got SQL. Now, for those of you who have the distinct pleasure of never having worked in sales, let me refresh that SQL is a common sales acronym. It means sales qualified lead. So it's somebody who's not a customer yet, but it looks like they could be a customer soon. It's a good potential customer. And of course, different from our world in data where SQL is the the thing that we like to select from where, that thing, the one that we do. So this sales director, he's excited. He says, yeah, we've got SQL. You can get us joins. I said, yeah, absolutely. Just tell me what you need to join. He said, we need to join customers. So I said, okay, I found your customers table. It's right here. What do you need me to join it to? I said, that threw him for a loop. I said, join it to. We don't need to join it to anything. We just need to join customers. I said, okay, that's a self join. And we can do that. We can do a self join. But here's the thing, depending on how we do it, we might actually end up duplicating your customers. And he said, wait a second. You're telling me that the data team can use our SQL to get new joins and they will double customers? I said, yeah, no problem. Absolutely. Data team can support. And he was thrilled. This is the best meeting he's ever had. He sent us off to do it. And a week later, we broke all of their production databases. All their sales reporting just came to a complete halt. We actually started double billing all of their customers. Yeah, they were churning out in droves. We weren't getting new customers. We were churning their old customers. We sat down with him. He said, this is not good. This is terrible. What's happening? This is not what you said. I said, we're doing exactly what you told us to do. And really, it's just an issue of miscommunication. We're speaking different languages. This communication is getting tough. Luckily for me, the sales director was very, very clear in his next communication. He said, Evan, you and your whole team are fired. Don't ever come to any more sales meetings. I said, okay, that's a left outer join. So that was rough. Communication with sales folks is particularly tough. And that's not the only challenge with being a director. I think the way you get around most challenges is by surrounding yourself with good people, with a good team. You want to hire good data scientists. And there's a hiring practice, maybe a bit controversial. People tend to have strong opinions, but do you offer a code challenge to candidates? Will you sit down, will you accept a coding challenge as part of the job search and interview process? And folks have strong opinions about this. And I think it's important to take a step back and look at it from both perspectives. Obviously, the employer wants to offer a coding challenge because they want the free labor. But as a candidate, you don't want to take all these coding challenges for every interview you get, because as a candidate, you of course want to lie on your resume, and coding challenge will find you out. So it's a tough balance, and that's why I've decided that if I ever get a chance to hire a data science team, which don't get me wrong, I don't have that chance. They don't let me hire people because of my ineptitude. But if I ever get a chance to hire people, I'm going to offer a coding challenge, but I'm going to make it fun. Instead of, giving this really difficult challenge, I'm going to say, hey, candidate, find a data set, whatever data set you want, and do some analysis, whatever analysis you want. And if you're an aspiring data scientist, well, doesn't that sound like it would be fun? I mean, who could not want to just be creative and go and explore whatever data set you want? And I tell you what, if that sounds fun to you, and maybe you have an opportunity to do that, I'm going to do something crazy in the next 15 minutes of this talk. I've done this data challenge. I've done it, and I have the answer key. I've got the perfect notebook. I'm going to walk through it with you. Let me transition this from stand-up comedy to sit-down comedy. See if I can do this without crossing my wires and spilling my stuff here. Ooh, I'm not that short. There we go. That's how tall I am. And I'm going to walk through this answer key here. Let's see. All right. I tend to have a magic touch with technology, so you're probably looking at my Amazon shopping list or something now, but I'm going to pretend that you're looking at this notebook that I'm going to walk through. This is an open-ended coding challenge, and here's your answer key. Okay. I'm going to share this notebook with you at the end of this. It's open. It's on my GitHub. And look, I guarantee you that if you use this in your next coding challenge, whatever the actual prompt is, just walk them through this notebook. I guarantee you will get the next data science job. And if you don't, then your money back. Okay. Not for this conference, for the code that I'm giving away for free. All right, let's see if I can figure this out here. So you want to make it easy. You want to make it readable for the interviewer. So you start out with sort of an overview of everything that you're going to see here, from getting the data, exploring it, and modeling it. And then we as data scientists, we always need a dustbin of artifacts at the end of the notebook where we've written code that we know is good and is supposed to work, but it just doesn't work yet. You don't want to throw it away. So you just throw it all at the end of the notebook. All right, here we go. Here's an overview. Okay, there's only 2 lines of code here, but there is a lot going on. So let me take a moment to explain what's going on here. First of all, writing code is hard. Okay, it's incredibly challenging and you should never do it. You should avoid writing code at all cost. Luckily, other people have written a lot of code and they have stored it in these nice packages. So you should always import a ton of every chance you have to import a package and use somebody else's code, you should do it. And the example here, I've only imported 2, but it's the 2 most important packages that every data scientist should import at the beginning of every notebook they have. First is pandas, because we're data scientists. We live in pandas data frames. Everything should always be a pandas data frame. And I've got this nice little trick here that maybe you catch. You can alias this package as whatever you want. Here I've called it best practices, because when I was a data scientist, I would often sit down to a code review with my senior and they would say, Evan, did you use best practices? And I could say, yeah, I did. See, look, I've imported pandas as all sorts of things. I import pandas as robust error handling, import pandas as cross-validation, whatever you need, you can import pandas as that and be tautologically correct. Second thing, you always want to import NumPy. Now, you want to avoid using NumPy. Okay, NumPy is like all kinds of math, like equations and formulas, and it gets super confusing. I don't know what's in there, but if you import NumPy, it makes you look smart. Like, look, see this notebook? I'm about to do some mathy stuff, so you know I'm legit. So always make sure you import pandas and NumPy. And you want to import all of your packages right here at the start. So anybody reviewing your notebook can tell exactly what you're doing. All right, now we need to find some data. And there are a lot of free public data sets, but we want something that can be fun. And I realized there's in scikit-learn, popular tooling, there's actually toy data sets that come in scikit-learn. What could be more fun than a toy? So that's what we're going to do to make this fun. And here I'm going to immediately contradict myself and go ahead and import another package, or at least another module here. And in these data sets in scikit-learn, we're going to look at all of them that start with load. Those are the things that are actual data sets. And we're going to look for something fun. So here are the data sets that come in scikit-learn. Breast cancer, not fun at all. Okay, depressing, the opposite of fun. Diabetes, oh my gosh, all right, maybe none of these toys are fun. If we just scroll to the end, these look benign at best or depressing at worst, until we get to the very end. And here's a fun one. It's wine. Okay, wine is fun. It's not depressing. Wine actually cures depression, if you didn't know. So that's a fun one. That's the one we're going to use. We're going to analyze this wine data set. And so here I'm reading it in, and I got a bone to pick with the scikit-learn folks. The default is as data frame to be false. So you always want to make sure everything we do is a data frame. Make sure you keep it as a data frame. And we're going to read it in here and take a look. Okay, here's what our data set looks like. We've got a bunch of features. Here's alcohol. That's the ingredient that cures depression. And then we've got a bunch of these other things here too that I can't pronounce, and then some target. All right. Now, if this were not an interview, if this were the real world, we would be done. We would just take this data frame and immediately throw it in XGBoost, and then all our problems would be solved. But because it's an interview, we want to jump through a few more hoops. And the first thing we're going to do is clean up the data a little bit. Now, one of the things you might notice right away that's a big problem, there are 178 rows in this data set. Like that, when people talk big data, this is what they're talking about. That's way too much wine to analyze. Like on my biggest party nights, I'm drinking maybe 6 or 7 wines. There's no way I could ever analyze 178. So we're going to sample that down here. In my notebook, I've got it at 7. That's quite a bit. Maybe depending on your tolerance, you could analyze more or less. And then we're just sampling from our wine data frame to get this sample. And I see that I've actually, does this work? Okay, this works, but I see that I've made a mistake because we're not using best practices here. We want to make sure everything is best practices. So we want to make sure, instead of this just integer hanging out here, we want to make sure this is a data frame. So we're going through all these unnecessary steps here to make this much more complicated in order to use a data frame. Okay, this should work. Oh, nope, because now it wants just a number here. So then that's okay. That's okay. That's okay. We can do this. It's a very simple data frame. There are just one row, one column. So we just call the first. Now we're using best practice. Okay, this is the way we want to do it. And we've sampled down our wine. And what do we have? We've got these 7 wines. Great. All these values associated with them. And then we've got our target, 1s, 0s, and 2s. Now, maybe you're a sommelier. Maybe you know a lot about wine. For me, I have no idea what a 0 or a 1 or a 2 is. So I need to go and put those targets into layman's term. And in my case, I did analyze each of these 7 wines, and I came up with sort of my subjective target for each one. The 0s were good for a fancy dinner. The 1s made my jokes funnier. Maybe you guys try sampling some of those now. And then the 2, there was a 2 in there. It made me go to sleep. So I put the new target map on here, and we can see that here's our old targets and our new description. Great. We've cleaned up our data set. We're ready to analyze. But again, let's do a little exploration. Let's understand what's really in there at first. So here we're going to do a correlation matrix. That's a pretty common way to see how our variables are correlated. Now, for me, a matrix sounds complicated. I like to try to avoid complication if I can. So what I've developed here is a correlation bar chart, where what we can see is for each variable, how correlated is it to itself. We can see most of these our correlation is a 1. So the variables tend to be perfectly correlated with themselves. So it's hard to tell. Maybe you could zoom in and see if they're exactly 1 or close to 1, perhaps even over 1 for those that are very correlated. But this is good data exploration. We're learning what's in our data. Next, we want to look at the distribution of our data set. Are they skewed? Are we missing a bunch of numbers? This is tough because a distribution of just 7 values doesn't really tell us very much. So what I've decided to do is just go ahead and plot a distribution of all of the numeric values in our entire data set all together. And that way we get this, this useless skewed distribution here that tells us there's some values that are really high and most are really low. So that tells us a little bit about our wine in exploration. And then third here, don't forget this is an interview. And if you're doing a coding interview, you better be able to reverse a linked list. Okay, that's mainstay in all coding challenges. So this has absolutely nothing to do with the actual data, but it is just copy pasted code from ChatGPT about reversing a linked list. And we've proven that we know how to copy paste code from ChatGPT to reverse a linked list. So that's always good to share with an interviewer. All right. Now we're to the fun part. This is the juicy part. We've got our data set. We've sampled it down. We know what's in it. We're ready to analyze. But what are we going to model? As data scientists, the possibilities are endless. We can do anything. We can do supervised or unsupervised. We can build an overfit model or like an extremely overfit model. But here we're trying to impress. So we want to do something tough, and we're going to do the hardest thing that data scientists can do, and that's causal modeling. Now, for the last year or so, I've been really into causal modeling because when I first read it, I thought it said casual modeling. That'd be good for me. You can just sort of relax and do some nice casual modeling. But now that I'm into it, I just love it. But it's not enough to say, let's just do causal modeling. Causal modeling answers a why question. We need to know why. So I analyzed all these wines one night, and I woke up the next morning and I felt terrible. I had a headache, my stomach was upset, my throat was so dry, and I wanted to know why. Why did I feel so poorly after analyzing that wine? I thought that was an interesting causal question. And so, how are we doing on time? We're doing okay on time, but look, I don't have all the time to walk through this complicated modeling pipeline. Here's another import, which is poor practice. But here is a modeling pipeline. Now, again, I'm giving you this code away, a link to this code. And I've made this so generalizable that you can use this causal modeling pipeline for any problem that you have. All it takes is a data frame, of course, because we only work in data frames, and this parameter that's level of complexity. Now, depending on the type of hardware you're using, you can make this very complex, or you can make this much simpler. You just put a number in there. Big, more complex; low, less complex. And you can see some of the work that's going on here, doing very complicated calculations. Let's just register this function in here. And then I feel nervous trying this live. Okay, I tried it before this talk and it worked fine, but we're going to feed it in. Maybe level of complexity 5 is a little too much. Let's use level of complexity 3, and we're going to try to use our wine sample and do this causal modeling. So let's see what we've got. Oh, it seems to be working. Okay, summoning the gradient spirits. That's good. That's a good sign. And is the model going to converge? Model successfully fits your data. Okay, the hangover culprit was wine number 6. Okay, that was our ZZZ wine. And just like that, we have shown to the interviewer that we can be a fantastic joke. And if they want a joke, then they could hire us as their data scientist. You can tinker with this. Maybe there's some specific things that you've noted that I haven't. Maybe you can scroll through the dustbin here, because this is code that I found that really should work, and I can't believe it doesn't. Generally, we want to import everything. I've tried, and for some reason, this doesn't work. We've tried to build a functionality to make everything into a data frame with the click of a button. That's not working either. I've also got this working though, and this is a QR code that will take you to my website. This is predictablejokes.com. I have written a book. If you thought these jokes were bad, these are like the best of the best. These are my tippy top jokes. Okay. I wrote a whole book full of even worse data science jokes, lots of puns, lots of goofy stuff in there. If you go here, you can check out the book. You can also see other performances that I've done. Usually they're not virtual. And so I get to see people's eyes roll in the audience instead of just having to assume eye rolls out there. But there's some clips that you can see of me performing live. Love any opportunity to perform live at any case in the future. So go there, check it out. You can see shows that are upcoming in 2025 or until I get canceled here. So I think we're very near the end of time. I haven't opened up the chat here, but if there are any questions, I feel like it's protocol to ask if there are questions after a talk. It's not really protocol after stand-up comedy, but we're sort of a blend of the two. So I'll ask for questions, but then I won't answer them. Thank you guys so much for coming. It's been an absolute pleasure putting this together, and thanks for giving me the opportunity.
Thanks, Evan. Are you on social media as well?
I am, yeah. My biggest presence, embarrassingly enough, is actually on LinkedIn. There's a link to it here. You can just search me, Evan Wimpey, on LinkedIn and give a follow there. And it's fun to try to tease between the times when I'm being serious and when I'm being a comedian. So best of luck.
Awesome. Well, thanks, Evan. And I hope to see you at a future PyData conference, and probably in person as well. So we can see everyone there.
Perfect.
All right,
Thanks
everyone.
very much to the PyData team here.
Yep, absolutely. Thanks, everybody. Enjoy the rest of PyData Global.